Hello everybody. So today's lesson I decided I'm going to record it from a bit of a different place. So welcome to my balcony. It's actually a nice crispy morning, perfect day to go outside a little bit and take in the air and then look around. It's a quiet morning. There's not a whole lot of drones flying by today, only a few helicopters carrying stuff. And this is my pigeon. His name is Bartholomew. Hey, Bartholomew. Oh. Okay, cool. So let's go ahead and go inside and talk a little bit about this new operation called the factorial. So let's go ahead and see how that works. All right, so we are going to be working here. All right, so we're going to talk a little bit more today about this new operation called the factorial. Now, of course, we have lots of operations that we've worked with before, right? Addition, subtraction, multiplication, division. This is another mathematical operation. It has an interesting symbol. The symbol for the factorial is the exclamation point. So here's the exclamation point. So what does it mean if I write 7 and then factorial? Well, let me go grab my marker. There you go. So what does it mean when I have 7 factorial? What that basically means is what I'm trying to write. So this operation of the exclamation point, it doesn't mean, yay, 7. What it basically means is I take the number 7 and I'm going to multiply it by every single natural number that comes before 7. So that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 to give us 5,040. So that's what the factorial operation does, is it takes the number that has the factorial and it multiplies it by every preceding natural number that comes before it, right? So for example, if I want to take 5 factorial, right? So 5 factorial is going to be what? It's going to be 5, right? This number over here. And I'm going to multiply it by every single natural number that comes before it. So 4, 3, 2, and 1. 5 times 4, 20. 20 times 3 times 2, 6 is 120. Now, something else to keep in mind about the factorial is that the 0 factorial is defined to be 1, just because that's going to help us a lot in our calculations when we use the idea of a factorial in places like calculations of probability, combinations, and permutations. So you're going to see this popping up quite a bit there. So that's something useful to keep in mind, is that the 0 factorial is 1, and then when you work with factorials, you don't notice we're not using any negative numbers, right? It's just simply the number that you want to apply the factorial to and then multiplying it by whatever number comes before it, natural number. Let's look at another example where we do some operations with factorial. So what if I have 6 factorial divided by 4 factorial? So be careful, you don't want to start simplifying fractions the way we normally would, because factorials work in different ways. You want to take care of the factorial first. So let me show you the long way of doing this and then the short way. Now the long way of doing this would be what? So I would take what? I would take, if I break apart the 6 factorial, it would be 6, 5, 4, 3, 2, 1. And then the 4 factorial will be what? 4, 3, 2, 1. Now at this point, I'm going to be inclined to cancel out the 4, right? Because 4 over 4 is 1. That cancels. 3 over 3 is 1. That cancels. 2 over 2 cancels. And 1 over 1 cancels. But that's the long way of doing it. But notice, this over here, 4, 3, 2, 1, right? That's the same thing as 4 factorial, right? Let me erase this piece so that my 4 looks better. And then this over here is obviously the 4 factorial here. So the shorter way of doing this problem, really, instead of writing it out like this, is break apart the factorial in the numerator until you get to the next biggest factorial, meaning 4. So you're going to have 6, 5, and then 4 factorial, right? And then over 4 factorial. So that's the shorter way of doing this. Notice how what we wrote here, all right, let me make the multiplication sign a little bit better there. There you go. Notice what we wrote over here is exactly the same idea as here, but in a shortened version, because I didn't want to write out the 4 broken apart. What I did is instead I shortened it by just writing that this is the 4 factorial. Now, crossing out the 4 factorials, now I can do that. It's the same thing as crossing out each individual numbers here, but it saves us a lot of writing, right, and a lot of calculations there. So now crossing out the 4 factorials, because anything over itself is really just 1, leaves us with what? With just 6 times 5, which is 30. So then the answer there is 30. Now let's go ahead and see how useful this is when we're working with bigger numbers. Oh, let me get a little bit back. There you go. When we're working with bigger numbers, this is even more useful, because imagine us having to break apart 34 factorial. That's 34 times 33 times 32 times 31. That would be a lot to write. Instead, what am I going to do? I'm going to break apart the top factorial until I get to the next biggest factorial, so until 32. So that's 34 times 33 times 32 factorial over, and here's, I'm just going to copy 32 factorial. So now anything over itself is 1, so that we can cancel that. So 32 factorials cancel, leaving us with what? 34 times 33, my equal sign, here's better equal sign, to give us how much? 1, 2, 2. There you go. 1,122. So that's the idea, a quick overview of factorials, right? That you are definitely going to use anytime we're going to calculate probability, specifically when we're going to play with combinations and permutations. So before we go into those sections, let me actually give you a little bit of a tour of this place. We can maybe go outside to the other side of the balcony and see the view from there. So let me walk over here. Let's go through the corridor. All right, it's a little bit messy. Don't mind the mess. All right, resume. I'm gonna keep going. All right, so let's go ahead and go outside. Ooh, it's nice out. It's nice and beautiful. Whoa. Hello. Would you like to learn about factorials? Maybe not. Maybe it's a better idea if we just go back inside. So let's just go back inside. Yeah, much better if we hang out over here with our nice, wonderful, comfortable factorials. All right, everybody, I'm looking forward to us working more with the factorials, specifically in combinations and permutations, and I will see you then.